Hey all, so we're looking at target 3.6 today, which is using that equation Q equals mc delta T to solve calorimetry problems. And so using that equation, we can solve for any of those variables. Let's take a look really quick. We've got Q equals mc delta T. So remember, Q is heat in joules, M as mass, mass is in grams. C is your specific heat value. Remember, that is specific for different materials, and unless that's what you're solving for, you will be given that. Mostly we are looking at water, so we're typically going to use the water values. And if you remember, that is in joules for every gram times degrees Celsius, because specific heat is the amount of energy it takes to change the temperature of 1 gram of a substance by 1 degree Celsius. So if it has a low specific heat, it's easy to change the temperature of the substance. If it has a high specific heat, it's hard to change the temperature of the substance. And then lastly, we've got delta T. If you remember, delta means change in, so that is T final minus T initial, change in temperature. And that's in degrees Celsius. Okay, so we've got our Q equals mc delta T equation broken down now. And if you don't have this written down at the top of your worksheet, I would write it down as a reminder to yourself so you remember what is what in this equation. Okay, so it says a student must use 225 milliliters of hot water. If you remember, so we need a mass, not a volume, but if you remember, the density of water is 1 gram for every 1 milliliter. So if you ever have a volume of water, you can just straight convert that to mass of water, again, because the density of water is 1 gram for every 1 milliliter. Note that only works for water. Only works for water. Any other substance has a different density. But for water, 1 gram equals 1 milliliter. Okay, so they have a mass of 225 grams. And it's water. So that means, and it's liquid water specifically. So that means our specific heat is 4.18 joules for every gram times degrees Celsius. That is at the top of all of your worksheets, those values that you need. So remember, we have the specific heat of solid water, ice, is different than the specific heat of liquid water, which is different than the specific heat of water vapor. So we do have to keep track of whether it's a solid, a liquid, or a gas. Usually it's a liquid. So we use that 4.18 joules over grams times degrees Celsius. And we're calculating the amount of heat required to raise the temperature of the water from 20 degrees Celsius to 100 degrees Celsius. So remember, I do T final minus T initial. So T final is 100.0 degrees Celsius minus T initial is 20.0 degrees Celsius. And that equals Q, which is what I'm solving for. It says calculate the amount of heat required. So I'm solving for Q. And so from here, I'm just going to put this in my calculator, and I'm just going to make sure that I do keep those temperatures in parentheses when I put them in my calculator. Otherwise, my order of operations is going to be all kinds of messed up because we know we do multiplication before we do subtraction. So just make sure you keep that delta T in parentheses when you put it in your calculator, or it's going to get all kinds of messed up. All right, so I'm going to set my calculator, and I get 75,240 joules. Remember, Q is in joules, and we can see that because grams cancels grams, degrees C cancels degrees C. I'm left with joules, so that makes sense. Let's talk sig figs. So switch my color here. I've got 3 sig figs here in 225. And then my specific heat is 3 sig figs. And then when I subtract these, I get 80.0 degrees Celsius, which is 3 sig figs. So it looks like for my answer, I get 3 sig figs. Right now, my answer has 4 sig figs. So that means we are going to round it so that we only have 3 sig figs, which would be 75,200 joules. So I know I get 1, 2, 3 numbers there. I look at that 4, I see, oh, that is less than 5, therefore it just becomes 0 instead of rounding up the 2 to a 3. So it's closer to 75,200 than it is to 75,300. So that is my answer, 75,200 joules. And again, you could solve for any one of these variables. You could solve for mass, you could solve for delta T, you could solve for T final or T initial. It's just going to require algebra. So as long as you know where to plug everything in, from there, it's just algebra. So keep an eye on your units, use your equation, and you should be good to go.